Hey, good afternoon, everyone. Welcome to Flint and Walling's 2019 series of web conferences. My name's Dan Painter, the Product Training and Development Manager here at Flint and Walling, and I will be hosting today's web conference live entitled City Water Pressure Booster Pumps. The objective behind this brief web conference is to virtually share with you about everything you're going to need to know about this particular product. And so with that, we're going to get started. The likelihood of this running a full hour is pretty slim, but these web conferences, we slate an hour. Most of them probably won't run much more than 30 or 40 minutes, but we'll see how this goes. Anyway, for us to go ahead and get started, first of all, there are two models of this city water pressure booster system that are available, and hopefully your video and audio is all coming through clear and clean. Picture of the city water booster should be on your screen. The two models that are available is what's model number VP05. That is a half horsepower, and also the VP10, a 1 horsepower model. There's no doubt that looking at the last couple of years purchase history on this product, that the VP10, the 1 horsepower, is the overwhelming majority of the models sold in this category. So the 1 horsepower is without doubt the most popular model. So when we look at this city water booster, one of the cool things about it is it's very integral. Everything it's all in one. The switch, the tank, everything's all together here in a very tight package. This booster is about 14 inches from front to back and approximately 9 inches high. So it's a real tight, compact product. Easily fits in most places or most applications. So very small. What we're going to do is we're going to start off, and I'm going to just identify some of the components on this system for you. And what we're going to do is we're just going to work our way from the front of this pump to the back side of it. So starting off with, we've got a tank that's up front. As I mentioned a few minutes ago, this city water booster, everything is integral to the pump itself, and so the tank sits up in the front. It's a very small tank, but in this application it functions just fine. Holds a few ounces of water. Something to be aware of regarding the tank is that it does come with a pre-charge air pressure. So for the VP05, there should be 25 pounds of air in that tank. And for the VP10, it's 35 pounds. Now, if you want to check the air pressure or you want to add to this tank or detract from it, the little black cap that's located on the front of the tank easily threads off, and right below that black cap is an air valve, or some people would call it like a snifter valve, very similar to a tire. And so you can easily add air or take air out of the tank through that snifter valve. When we talk about the pre-charge, the 25 psi or the 35 psi, dependent upon model, that's the amount of air that should be in the tank when the tank is completely empty, meaning no water in the tank. So on a startup, it may be worth just putting a tire gauge on there and double checking to make sure that air charge is present before you begin. Moving on back to the pump housing itself. This pump housing sits just behind the pressure tank or the storage tank. It consists of a couple of components worth mentioning. One is a stainless steel impeller. So that sits back there, that's driven by the motor. And the other thing that Flint and Walling has done with this particular product is we've embedded a thermal sensor into the pump housing itself. And on this type of product, that's a key feature, because there are lots of city water booster systems on the market today. And there's been some issues with overheating. So if you've got a situation where a pump happens to be rapid cycling. These are not exclusive to Flint and Walling, by the way. This carries across the industry. If you get pumps that are rapid cycling, if you get pumps that, for whatever reason, run dry, or in the case of a deadhead situation where the pump's been activated but the valve is closed and there's no place for the water to go. All these conditions can create heat rise. And so many of these city water booster systems are installed with PVC piping and adapters, so that if you have a plastic male adapter threaded into the pump and the pump gets hot, it's possible that you could get enough heat to deform the plastic fittings and create a leak. So we put a thermal sensor in there that detects this heat rise should it happen, and would shut that pump down, shut it off, long before the heat would ever get to a point where fittings could be damaged by that. So keep that in mind. There's a thermal sensor that's embedded into the housing of the pump just for additional protection. Moving on back, we'll identify the inlet and the outlet of this pump. The inlet is on the side, and the outlet or the discharge comes right out the top. Another cool thing about this version of pump is that these inlet and outlet fittings are held in place with stainless steel 4-bolt flanges and gaskets behind them. The 4-bolt flange proves to be a much more rigid connection to the pump in case someone gets, wants to over-tighten fittings, for example. That's not uncommon, and with the 4-bolt flange, it's very difficult to damage the pump by over-tightening the fittings. The inlet side, the side that you're looking at on your screen, will also have a stainless steel inlet screen. It's hard to see in this picture. I've got a red dot over the top of it, but any water coming in the inlet of this pump will go through this stainless steel mesh screen to keep any particulate debris from entering into the pump itself. So there's your inlet and your outlet adapters. Again, they're stainless steel 4-bolt flange. On top is, in the little module located between the inlet and the outlet, is where the flow switch is located. This pump is activated by a flow switch, and in order for the pump to come on, one or two things must take place. Either a flow demand of 0.7 gallons per minute, which is not very much, but you have to have a flow of water that meets or exceeds 0.7 gallons per minute. That will lift the flow switch and activate the pump. And a couple other ways this pump will come on is low water pressure. So if you've got a VPO5, for example, and the incoming water pressure drops below 25 psi, this pump will automatically turn on, and 35 psi would be the threshold for the VP10. So either you've got pressure below the listed pressure on your screens for each model pump, or you must have 0.7 of a gallon per minute demand required in order for it to come on. The flow switch also acts as a built-in internal check valve as well. So that's why that suction screen or that inlet screen is located there, to protect any debris from entering into the flow switch area and where it must operate and move up and down. Moving on, between the flow switch and the outlet of the pump, right at the very top, is what's called an air relief plug. This plug is designed to assist in priming the pump, which we will be talking about in a few minutes, but I want to make sure you know where that's located. And like I said, it's just up there on the top. It's removable, and it will assist in the priming of the pump. Moving on back is the electronics for this pump, and within that is some protection. I'm not sure this is common with all city water boosters that are on the marketplace today, but certainly with this model, City Water Booster, you do have protection against dry runs, deadheading, or rapid cycling, all of which, again, can create considerable heat rise and cause damage to the pump if it's not eliminated or corrected. So once again, a good reason to have thermal sensors embedded into the pump itself, just for those things that may occur in which you and I have no control over. So the motor, again, this is going to be available in either 1/2 horse or a 1 horsepower motor. They both will operate off of 115 volts, and the motors are rated for continuous operation. So continuous rating on the motor. The very bottom of the pump is a mounting base. It is a composite base with a full 4-bolt pattern, so that this pump can be mounted securely to a pad or a piece of wood of some type, just to help minimize vibrations. So with that, we've pretty much walked through very quickly, albeit the various components on the pump. But again, you've got your tank up front, you've got the motor house or the pump housing right behind it. The inlet and the outlets are right there, along with the flow switch and the electronic diagnostics and protection located just behind that. Next, what we're going to do is walk through an installation. And in an ideal situation, this is how one of these City Water Boosters would be installed, so that when you leave, you've pretty much got the pump set up for anything that may occur outside the pump. And I'll cover some of those for you. These are all in the instruction manual. And by the way, looking through competitors' instruction manual, this typical installation is not uncommon at all. So as we look at the pump from the front side, and again, what I'm going to be talking about in regards to installation would hold true for either model, the 1/2 horse or the 1 horsepower models, either model. But again, as we discussed, the inlet is located on the side of the pump, and the discharge comes right out the top. So when installing these, you're going to bring water into the inlet from the city water supply. This is a 1-inch fitting that's on the pump itself. So you're probably going to be bringing 3/4 or 1 inch into the pump, and then the discharge is going to go out to the home or the irrigation system. And again, this pump has got a 1-inch discharge and a 1-inch suction. Ideally, when installing this pump, you may want to consider, as this is pointed out in the instructions, you may want to consider a couple of unions. These unions located on the discharge and the suction or inlet side of the pump will allow for the pump to be easily taken out, repaired at some point, or serviced at some point, or perhaps in the winter, just to winterize it. It just makes the pump very, very easy to remove if there are unions on there, along with a couple of valves, an inlet valve and an outlet valve. And again, as I mentioned, these are all pointed out in the instruction manual. Something that is not very common but should be practiced is a loop around the pump itself. So let's just look at this for a second. You incorporate a couple of T's, one before the inlet valve, as you can see on the left-hand side of your screen, and another T on the after the outlet valve on the right-hand side of the screen. And what this loop allows is it allows for a bypass. So it allows for a bypass around the entire pump. And there are times when having this system plumbed in this way would be favorable. One time I can think of is if there were a power outage. If you happen to have a power outage, well, that pump's not going to run anymore. And so if you don't have a bypass around the pump, then all the water that's going to be coming through there is going to go through a pump that's not pumping and add just even more restriction of flow and pressure. So having a bypass valve in place, should the power fail, you could close the inlet valve and close the outlet valve, and then go at the top and open up the bypass valve, which would now allow water to move through the piping unrestricted by not having to travel through a pump that is not being energized or is not running. So a bypass around the system is also recommended. Continuing with the installation, and this is true with virtually all city water booster systems that I've ever seen as I've traveled about. But these pumps, these type of pumps, and this is not exclusive to the F&W models, but all of them, they will not function properly if the incoming water pressure is too high. So if the incoming water pressure is too high, we can install a pressure regulating valve ahead of the on the inlet side. This some people might refer to this as a pressure reducing valve. And you might be asking yourself, well, at what point do we consider the pressure being too high coming into the system? Well, depending on the model, if you have a VPO5, which is a half horsepower, the incoming pressure, if it's above 30 psi, in order for that pump to function, you're going to want to put a pressure reducing valve ahead of it. I know it seems a little strange to think we need to reduce the pressure down before we can give it a boost up, but that is the nature of these type of pumps. 50 psi is the threshold for a VP10 or a 1 horsepower. You know, part of me says if you've got something above 50 psi, I'm not sure this is a real good application for a booster pump anyway, because again, 50 psi is not a bad incoming pressure. So again, we would consider putting a pressure reducing valve or a pressure regulating valve if the incoming pressures are above those thresholds listed on your screen. As insurance, and again, this is recommended, although quite frankly, rarely performed, but as added insurance, and this, I'm just coming out of the instruction manual with this, is a pressure regulating valve on the discharge. The purpose for this, as I mentioned, for added insurance, it's to ensure that the maximum water does not exceed, the maximum water pressure, sorry about that, does not exceed local plumbing codes. So having a pressure release valve on the discharge would keep the unit from, would give the unit protection in the case of overpressurization. Short of that pressure reducing valve, having a pressure release valve or a pressure regulating valve, having a pressure release valve. If you don't put the regulator in, put a pressure release valve in. Kind of like what they put on water heaters, right? So if the pressure gets up, pressure release valve opens up and relieves the pressure. So, and of course, any pressure release valve ought to have a drain, and that drain should be directed to either like a sump pump basin or a floor drain of some type, so it just doesn't arbitrarily just flow out of this pressure relief valve. But what I just covered for you is the ideal installation with all the safeguards in place. Many times, as I mentioned, when I go on these, I just basically see an inlet and an outlet and very little beyond that. But it is recommended, just so you know, and is included in the instruction operator's manual. But at this point, the installation of this type of pump is complete. I'd like to talk to you a little bit about priming the pump next. And so when priming the pump, this is the steps that you would use to prime this pump. So after the installation is done and with the pump powered off, okay, so there's no power to the pump, the installation is complete. Now we're going to prime the pump. Step one, The first thing we're going to do is we're going to unthread that air relief valve plug that I showed you when we were identifying some of the system components. Again, that plug is located just between the flow switch and the discharge of the pump. Step 2 would be to close the bypass valve. So you close that bypass valve and then open the inlet and open the outlet valves slowly. This will allow water to come into the pump. It will vent the air off out of the air relief plug, and you'll continue to let that water run in slowly until the pump cavity has had a chance to remove all the air and you begin to get water out of that air relief plug. Once you've done that, that kind of ensures that we've got the pump housing and the line coming into the pump these are much easier to prime than a centrifugal pump that's using lake water or cistern. These are city water supplies. Water is being fed right to the pump itself. And so once you turn the valves on slowly so that this doesn't take very long to prime, but you want to allow the air to purge out the air plug at the top. And once water comes out of there, then you can go ahead and retighten that air plug and you are fully primed. So very, very easy to prime this pump. So we've identified some of the components. We've talked about some of the installation and briefly discussed the priming. I want to move to the performance of this pump now. This pump is again, it's by its name, it's a city water booster pump. And to give you some idea, I was on a job a few years ago, and one of our distributors, outside sales guy, had taken a pump home and installed it in his own home. I believe it was over the weekend, but he invited some of his customers to come over, and they were cooking dogs and hot dogs and bratwurst, and they could actually observe the difference that this city water booster pump made in his irrigation system. So what you see on your screen now is a picture of his irrigation system prior to powering the pump up. Once he powered the pump up, you can see the difference that it makes. And so you can see with the pressure boost that it made a big difference in his irrigation system. This area here, called a rain curtain, was much more dominant after the pressure boost than it was prior to. And so he got much more effective coverage with the irrigation as it moved out across his lawn and landscape. Performance charts. There's two charts on here. The one at the top is basically for the VP05, the half horsepower model. The one down at the bottom is for the VP10, the 1 horsepower model, with two notations above each talking about that incoming pressure. Now, if it's too high, we need to bring it back down so that we can make the pump function as it's designed to do. But just to give you an idea of how to read these charts, let's look at the bottom chart, the one for the VP10. And for an example, if you had an inlet pressure, you see the pressure column over on the far left-hand side. If you had an inlet pressure of 30 psi, and coming across the top of the chart are flow rates in gallons per minute. It starts at 3, goes to 21. For irrigation, what we'll do is we'll probably pick out that 15 to 18 gallon per minute range. So you got 30 psi coming in. It goes through this booster pump, and the system pressure will then become dependent upon flow rate. At 15 gallons per minute, you're going to take that 30 psi to 70. At 18 gallons a minute, you're going to take the 30 psi to 65, as you can see indicated on the chart. It's important to understand that the 70 and the 65 values that you see out there in the body of the chart, this is total system pressure. This is not the boost you're getting. It's the incoming pressure along with the boost. So inlet pressure plus the boost is going to give you your system pressure. So it's not a 70-pound boost. It's rather a 40-pound boost on a 30-pound incoming pressure. I think you all probably got that pretty good now. So these pumps put out a lot of water, a lot of pressure, and great for applications. I want to talk a little bit about the protection located in the back of this pump. What you have is you've got protection against dry run, deadheads, and rapid cycling. So for the dry run and the rapid cycling, the pump will shut down to protect itself. Hourly, it will come on to determine if the conditions still exist. So it won't shut down and stay shut down. It'll come back on and detect whether the condition's still there. If the condition went away, then the pump self-corrects and it's back on stream again. In the case of a deadhead, the pump will shut down to protect itself. And then once water flow is restarted, the pump will automatically restart itself as well. So I'm sure everybody understands that a deadhead situation is typically when the outlet of the pump, the supply line that's going out has a valve that's been closed, and so the pump is pumping against a closed valve. That's referred to oftentimes as deadhead. So in either case, deadhead, rapid cycle, or dry run, this pump does have protection so that it just doesn't sit there and self-destruct under these conditions. One thing to note, you can reset the pump manually if you unplug it for about 5 seconds and then plug it back in. The protection on the back, there'll be a label on the electronics portion of the pump. This is what that label looks like. Let's just go through this real quick so that we can understand what each of these means. So if the green light is illuminated, indicates that there's power, and it will always be on when connected to power, irrespective of whether the pump's running or not. It'll just be a quick visual knowing that the pump has power. If you get a red button or a red light that illuminates, that is going to be an indication of some type of failure. And so turn on when the red light will turn on when there's a demand for water. So when somebody opens the irrigation system up or the irrigation system starts to run and that red light comes on, that's an indication that the pump's not getting any water, and so it's under a dry run condition. And then the amber light, the yellow light at the bottom, it will turn on when water is being used. That means it's under normal operation. So when water is being used, you'll have a green light on and you'll have a yellow light on. The only time the red light comes on is if there's a failure of some type, but the yellow light will remain consistent as long as water is being used. If, on the other hand, the yellow light turns on intermittently when no water is being used at all, and it's sitting there and it just kind of comes on and off, it flashes, that'll indicate a leak in the system somewhere. So again, this pump's got both protection and diagnostics on board. To wind this down, the ambient temperature, this is just some operating conditions. So the ambient temperature range is anything from 32 to 104 degrees Fahrenheit. Freezing or removing the pump from maintenance. The pump and all the piping must be protected from freezing. And where we're located here in Indiana, that's a big deal right now this time of the year. But if you want to winterize the pump, unplug it from the power source. Close those inlet and outlet ball valves, open the bypass valve up, and relieve the pressure from the pump. And then remove the pump using the unions and the union connections. So again, pretty easy to, if you've got the unions in place and the valves in place on initial installation, it makes it very, very easy then to service the pump or remove it to keep it from freezing. And then lastly, of course, you want to store the pump in a heated area. Everything discussed thus far in this web conference is certainly available in the owner-operator manual, so that everything's in there, parts breakdown, troubleshooting guide, so on and so forth. I do want to make you aware that if you would like a copy, of this training module. There is a City Water Booster training module available that has everything in it that you've seen on your screen today and then some. On the bottom of your dashboard, there should be a little button down there that you can click and you can download a PDF version of our City Water Booster Pump training module. Pretty cool. And then there's a little quiz in the back, just FYI. If for whatever reason you're not successful downloading it off this conference call, that's the form number for the City Water Booster, FW2041, and just drop an email to marketing@flintandwalling.com, and we'll be sure to get your copy sent out to you straight away. I'm looking up, and we're 35 minutes into this. We're going to end in the next 2 or 3 minutes. So as I mentioned, rarely will these typically run 1 hour. But our next web conference will be next Friday, same time, same station. The title of next week's web conference will be Irrigation Pumps Overview. This objective there is for you to be able to identify a variety of different pumps used in irrigation by simply a visual inspection. You don't have to run off and look at a model number, snag a catalog, go online. My objective is that you can look at a pump visually and immediately determine what type of a pump that is. And so that's what we're going to be covering next Friday on this web conference. You can also go to our website, flintandwalling.com, and click on the training. And I think most of you here that registered today has already done this and been through that. Click on the training, and you'll see that we've got the entire web conference roster or schedule for the next couple of 2 or 3 months listed on there. And you're welcome to any of those that you'd like to attend. With that, I'm going to conclude the web conference for the day. I do appreciate your time, and I wish you the best of weekends. Thank you very much.